Today we are going to be discussing about sorting algorithms in Java. It will be a hands-on workshop and I will be diving into the most asked algorithms and the coding interviews. Most of you already know me. I'm Preeti, a Beta Microsoft Learn Student Ambassador, and I want to thank you all for joining this session today. So today's agenda is going to be like I'll give a sorting intro, like what is sorting, etc. And then I will be discussing few sorting algorithms along with the hands-on of code in Java. And then I will be recapping whatever I have told today. And then we will be having a Q&A session where you can answer in the Q&A box. Or you can even on your mic. So the codes will be written in the VS Code, that is Visual Studio Code. It is a code editor which is by Microsoft, and it has multiple plugins and all. So that is a very useful tool. So without any further ado, let's start with introduction and why sorting matters. So sorting is a fundamental operation in computer science and coding interviews. So it is asked in almost every interview wherever you see. And at the start of the computer science only, we will be taught about this sorting. And so we already know what is sorting. It's like we have to just arrange the things in ascending or descending order. So how we will do it in the code, that matters. So there are few algorithms for sorting. Each algorithm is different. So each algorithm has different time complexity or space complexity, and we will be discussing all about that today. There are many problems in computer science also that require sorting as a first step. So if you have already a coding background, then you might know this problem of binary search, where we divide the array into half and then we will be checking if the middle element is greater than the target or less than the target. So it's one type of searching algorithm. In that searching algorithm, the first step is that we need the array to be sorted. So like that, there are multiple other problems also which require sorting as the first step. And these sorting algorithms are mostly asked in technical interviews. So if uh, if you are very good with this, then it will give you a good weightage. So now, where is the sorting applicable in real life? So there are multiple real world applications where the sorting is useful or used. For example, let us take the search engine Google. Even in Google, if we type something, they use the sorting in displaying according to the number of visitors or the most famous website, like that. And let us take the e-commerce websites like Amazon and Flipkart and Myntra, etc. In that also we have the filter options where we can filter according to our needs. And in there also we can sort in A to Z order. You have all. Another example is that the folders in your computer, they can be sorted in A to Z order or Z to A order or according to date or according to the name. There are multiple ways we can sort, not only according to the name, but according to the date of creation or modification, etc. And then other real world application is the scheduling and task management, like if we have some to-do list or etc. So these are all some real world applications where sorting is used. So now you know about sorting. Let me also tell about few important terms we need to know before diving deep into the sorting algorithms. So here we have the first term as time complexity. Most of you already know about time complexity. So this will measure how the algorithm's runtime increases with input size. This was just the definition. What this time complexity actually means is how much time the algorithm runs. We have few denotions, like we represent it with big O, that is capital O. So here is the general increasing order of the time complexity. So big O of 1 is said to have the least time complexity, is the best time complexity. And then the log n is a little more than that. And then n is more than that. Then n log n, then n square, n cube, 2n, n factorial, and n power n. So this is about time complexity. Now the second term which is important is the stable sorting. So this table sorting is so if okay, let me tell the sentence itself. Maintains the relative order of equal elements after sorting. So if we have two same elements for in the array which we are going to sort, then if the two elements are still in the same order after sorting, then it is called stable sorting. Else, if the places are changed, even if the same elements places are changed after sorting, then it will be considered as non-stable sorting. So that is about it. If you know this much about stable sorting, that's enough for now. Then the third term is in-place sorting. So in-place sorting means sort the data without using extra memory or space. That means we don't need any extra space for sorting. So here there is a small mistake in the time complexity. 2n will be less than the n square. So this shouldn't be here. So let me continue. Sort the data without using extra memory or space. So as I already said, we don't need any extra space. Then it is called in-place sorting. So if I just take one array and sort among themselves by using the swapping technique, then it is called in place. I don't need any extra memory or space or extra array so that I can store those elements and then put back. So that is in place sorting. And then the fourth term is divide and conquer. Here, as the name suggests, we will first divide it and then we will conquer it. Firstly, we will be breaking the big problem into small sub problems, and then we will solve each of them recursively. Means we will, this is according to the code where we call the code again and again for the small problems, and then we will combine all the results. So this is one type of algorithm. Today we are also going to see divide and conquer types of sorting too, like quick sort and merge sort. So this is a very important in term of interviews they ask most of the times. So we have seen about the important terms. Let's now dive into the sorting algorithms. So we have simple and efficient. Simple algorithms like bubble sort, insertion sort, and selection sort. Why this is simple? Now you will know after we learn about them. Then the efficient, merge sort, and quick sort. Again, you will know why these three are simple algorithms and why these two are efficient algorithms. As I already said, these two are divide and conquer algorithms. There will be time complexity difference also. Maybe that's why these both are efficient than these three. So let us see what algorithms work and which way. Firstly, let us start with the bubble sort algorithm. The name seems interesting, right? In this algorithms, there is nothing. It's simple. We just compare adjacent elements and swap if left element is greater than right. Else we won't swap. That's it. This is the basic idea of bubble sort algorithm. Now, what is the best case? So these are time complexities mentioned here. If the array is already sorted, then the time complexity will be big O of n. Else, it will be n square because we have to check all the elements from the start till the end. So you will understand the time complexity in the code. So now, stable, yes. Previously, I have told about stable sorting. In this In this algorithm, if there are two same elements present, then they will be in the same order even after sorting. That's why this is stable. So you can take a pen and paper and you can write 1, 2, 3 and 3. So those two threes, you can do a bubble sort on a paper, and then you will be understanding if the order changed or not. This requires a little pen and paper work, and then you will understand. So where this bubble sort is used is, this is the most simplest sorting algorithm. It is used in small data sets or even teaching purpose, like I am telling right now, right? So to understand sorting, this is firstly taught. Now, let us see a quick visualization of this bubble sort. So you can see, this is a little quick, but let me tell you. Firstly, the So you can see we are comparing every adjacent element, and if the number is greater than the adjacent element, we are moving it to the last. Like that, we are going to do multiple passes until we get the sorted array. That's it. Here we only need swaps and comparison. If the right side element or left side element is greater, we just want to move it to the right. We want to move the greatest elements to the right and smallest to the left. Here, repetitive comparison is there. That's why this algorithm is not much efficient and very simple. Now, let me tell you with an example. So, let me take an array which is unsorted, that is 5382. You know, it is not in ascending, neither in descending order. Now, what is step one is, I will see first element, that is 5, and then 3. So this 5 and 3 are not in the correct order. 5 is greater than 3, so I will swap them. So what I'll get is 3, 5, 8, 2. The first step is done. Now what I have to compare is 5 and 8. 5 and 8 is in the correct order, that is 5 is less than 8. So I have no problem here, so no swap is needed. Now, the next step is to compare 8 and 2. Here some problem is there because 2 is less than 8 and it is in the right position. So we will swap it. So 2 came here and 2 and 8. So now we have 3, 5, 2, 8. Now again we will start 3 and 5 comparison. 3 and 5 is in the right position. Yes, 3 is less than 5. And then 5 and 2. 5 and 2 is not in the correct position. So we will swap it. So we get 3, 2, 5 and 8. In the next step, we will compare 5 and 8. 5 and 8, no swap is needed. Next. Now again, we will start comparing from the first element. 3 and 2, are they in the correct position? No. So we will swap them. 2, 3. And then 5 and 8 is in the correct position. And then we will check for 3 and 5, correct position. Then 5 and 8, correct position. So we got the sorted array. That's it. We will compare each adjacent element after swapping till the end. Again, start from the start. Once we get the sorted array, we will stop. This is bubble sort. So much of work is needed to be done here. That's why this is simplest, but having the most time complexity. So now let me quickly show you the code of this bubble sort. I have already previously written the base code which is needed. So here you can see I have already written the main method where I have declared the same array, bubble sort of array, because I am going to call that method. And then I have printed the elements after we have performed the bubble sort. Here I have written the bubble sort method, which is static methods, because we are calling it directly without creation of objects. And then the return type is void because we are doing an in-place sorting, because this is in-place sorting algorithm. We don't need any extra memory. So now what I'm going to do is, firstly, we have to do comparisons. But let me first write the array length as n. So I will declare like this: int n is equal to array dot length. Now I will write two for loops because I have to compare each element with the next element. So let me take first for loop where I will start with I till n. And then inside this, now first element I will compare with all the elements. So the zeroth element must be compared with all the next elements. So here I will write another for loop, that is j, and I plus 1. Because when I is 1, then j will be 2. So if we are comparing the second element, we will start with the comparison with third element. So now j less than n, j plus plus. So now we have got the two for loops. Now the only thing we have to do is compare the elements. If array of j is greater than array of j plus 1. But here I will have to start the comparison from the start. So here it will be 0. And here it will be n minus I minus 1. So now I will be comparing each element with the next element. So now, why this is like this? Because once we have completed one iteration, one element will be going into the correct position. That is, the largest element will be going into the end position. So we don't want to iterate till end again. It will lead to extra comparison. So we are going to reduce the size of that array. So now, I have compared this array of j with j plus 1. What I will do is, if array of j, that is the left element, is greater than the right element, I will swap them. So I will use here temporary variable method. So I will store this array of j in here in temporary variable, and array of j will be given as array of j plus 1. Array of j plus 1 will be given the value of 10. That's it. So this is the bubble sort, simple bubble sort in place algorithm where we are using two for loops. So here, that's it. The simple swapping is happening. Now let me run the code and let's see. So you see, we got 2358 as the sorted solution. So let us go back into our next sorting algorithms. So the next sorting algorithm is selection sort. Selection sort. Find the smallest element and move it to the correct place. So as the name says, selection. We are going to select an element which is the least or highest and then put it in the correct place. If it is the least, then we will put it at the front, and if it's the highest, then we will put it at the last. But we have to follow the same, like if we are finding the smallest element, then we have to put, in all the iterations, we have to find the smallest element only, and vice versa. Here, all the cases algorithm time complexity is big go up n square. Now, is it stable? No. Swapping here may change order, because here, even if we don't even if the swapping is not necessary, the swapping happens. So we won't say this is a stable algorithm. And this is also used in simple sorting tasks when memory writes are costly. Now, let me show you how the selection sort works with the same example. So here it is, 5382. What we are going to do? From starting till the end, what is the smallest element? 2. So I'm going to swap 5 and 2. So I've got 2385. Now in 385, what is the smallest element? That is 3. So 3 is in the same position as 3, so we won't swap anything. And the next time, what is the smallest element in 8 and 5? So here we are not going to bother about the previous parts because they are already sorted. And then the next part of the array we are going to take care about. 8, 5. And in this 8 and 5, what is the smallest? 5. So it will be replaced with 8. So 2358 and we got the 2358. That's it. So now we got the sorted array. Let us now again see the selection sort code. So here for selection sort also I have written this already, the base code. So what I have written is the same array and selection sort is called here. And then we have printed the elements in the selection sort. So here also I will mention the array length, that is n. Now here again I have to iterate the entire element and find the minimum index element and then swap it with the first element, whatever ith element is there. So for int I equal to 0, I less than n and I plus plus. So I will declare that minimum index as min and I will start with that minimum index as I. So whatever element is there. I'm not starting with 0 because this can, so you will understand in the next iterations. Because once we sort the array and find the smallest elements, once we find the smallest element in the array, we place it at the first, right? Then we don't have any use with 0. That's why we are going to start with I because we don't know what that ith position value is at that time. Now we will start iterating again from I plus 1 and j less than n and j plus plus. So here what I am doing is here I am going from the next element till the last element. I am checking if if any element is greater than, if any element is less than this. If any element is less than the min, then we will swap. So we will take the first element and compare with all other elements. If any small element is there, then we will swap it with that. That's it. This is the idea here. So if array of j is less than array of min. So if we find any element at jth index which is less than the element present at minimum index, that is the I, then we will be updating the minimum index as j and finally we will be swapping after the algorithm because we have to iterate through all the elements. So by the end of the iteration, we will be getting the minimum element and now we will be swapping. So we will use the same temporary variable approach, int temp equal to array of min or j, whatever. Now array of min will be updated with array of I because we are swapping ith element with the minimum element and array of I equal to 10. We have updated the minimum with the jth element. So now we are going to swap that with the ith element. That's it. Now I will be running this code and it will give the same output, that is the sorted array. This was about the selection sort. We will just find out what is the smallest element, and then we will be putting it at the start. And we will continue the process from the next element again, and we will get a sorted array. This is also a simple algorithm. Now let us quickly go into the next algorithm. So our next algorithm is going to be insertion sort. So this is insertion sort. Here, insert elements into correct position in a sorted subarray. So you will understand this more in the example. Basically, the selection sort and insertion sort is little confusing at the start, but once you get a practice of it, you will be understanding. And about the code, there are multiple ways of writing the code. It is not the only way. The way I have written is not the only way. And here insertion sorts, best case is big open and worst case is big open square. So here the time complexity is again based on the comparisons we make. If this array is already nearly sorted, then it will be big open. There will be less comparisons. And in the worst case, if nothing is sorted or it is reversed, then it will be big open square. Even this sorting algorithm is stable. Again, as I said before, we have to put a pen and paper for that. And use cases is nearly sorted data or small data sets. This is also used with small data sets. Now let us see a quick example for insertion sort. Here what's happening is, firstly, we will check if 5 is sorted already. We will start with the first element and check with the left elements. So if 5 is sorted, there is nothing greater than the left. So we will keep it like that. Now we will start from 3. So 3 is smaller than 5, right? So I will have to insert this 3 before 5. So I will swap them directly. 3, 5, 8, 2. So after that, what we will do is, now I will start with 8. 8 is bigger than 5, yes. 8 is bigger than 3, yes. So 8 will be here only. So there is no swapping needed in this case. Now 2. What about 2? So 2 is less than 8, less than 5, and less than 3. What we have to do is we have to move all these 3 and then insert this 2 at the start. So insert 2 at the correct position by shifting the elements. All these elements will be shifted one by one. So 2 will be swapped with 8 and then this 2 will be swapped with 5. So I'm just saying, so then 2 will be swapped with 3 and then we will get the correct one. So this is basically insertion sort algorithm. Now let us see the code quickly for this also. Let me open the VS Code now. So again, the same array and same printing. I have written this and in this itself, the method, so that we don't need to declare again. Now, I will start by writing the for loop for int I equal to 0, I less than n, and I plus plus. We are going to start with the first element, right? Now what I will do? So I will declare a element called j, that is a variable, and I will write it as I. Why, you will understand quickly. So while j is greater than 0 and array of j minus 1 is greater than array of j, what we will do is, what this step will do is, we will check every previous element of the current element. So this is basically for doing the operations, we are taking another variable. So this j we are using for comparisons. So while j is greater than 0, because we are going to always look for the previous element till the index 0. As I have shown in the example 5832, first I will take 5 and I will check whatever elements are present before that until the index 0. This is 0 itself, so we are not going to check further, like that is before that. But now coming to the eighth one, eighth element, the element 8, which is at the index 1. Here what I am going to do is, here the index is 1. I will compare it with its previous element, that is still index 0. So until j is greater than 0, I am going to do comparisons until then. And whenever I will find the previous element is greater than the current element, that is this, then I will be swapping it. Here what I'll do, simple. I'll just swap in temp equal to array of j minus 1 and array of j minus 1 equal to array of j, and array of j will be temp. I have swapped it successfully. So 8 and 5 will be swapped. Now what I'll do, again I have to compare it with the next element, right? So I will have to do j minus minus. If we have done the swapping, then we have to check it with the next element until the j is greater than 0. We have to continue the comparisons and swapping. This is about the insertion sort. Again, if we run the code, we will get the same output. That is 2358. Simple. We have finished the important simple sorting algorithms. Now it's time to dive into big algorithms, that is merge sort and quick sort. These are going to be very interesting. So insertion sort is done. Now coming to the merge sort. Here, we will divide the array, merge sort. We will divide the array, sort them recursively, and then we will merge the sorted halves. Here merging happens. That's why merge sort name came. Here the time complexity is always big O and log n. I will tell you in the code about this. Table, yes. Use case, large data sets and linked lists. So this is an efficient algorithm which uses extra space also. I will now show the explanation of that using the same example. The first step, what we are going to do, we'll just split it. What I'm going to do is, I'll break the array into two parts, that is two halves, and then again break those halves into halves until we get single elements. So here what will happen? 5382, I will break into 53 and 82. And in the next step, I will divide them again into 5, 3, 8, 2. Now this is going to be easy to sort. The first two elements I will be sorting, that is 3, 5, and then I'll get 2, 8. And then those two groups I will be sorting again. So let me tell you. Merge the small groups back together in order. So this 5, 3, after splitting, now I will be merging them back again by keeping it in the correct order, that is 3 and 5. Because 3 is smaller than 5, we are going to sort in the merging process. And then this 8, 2 will be merged, 2 and 8. So now we have got again these two groups. These two groups will be again merged using sort. So now 3, 2, what is smaller? 2 is smaller. So I have put 2 first, and then 3 and 8, which is smaller, 3 is smaller. So I put 3 and then 5 and 8, which is smaller, 5 is smaller, and then 8 is small. 8 is the last element left, so there is no comparison. I will put it directly. So 2, 3, 5, 8 directly. We'll just first split the elements and then merge it one by one. We will take the elements and merge it, and those arrays again I will merge it. You can see here I have to create here new arrays. That's why here a space complexity is also needed. We will use some extra space. That means this is not in place sorting algorithm. Now let us dive into the code now. Let me open the VS Code again. Here I have written merge sort 0 to length. That is the last element, and then we will be printing it. So in this merge sort, what we are going to do is we have to split it into halves, right? And then merge them. So here there is a condition if left is less than right. What we will do is I'm going to write into mid, that is the middle element, because I have to divide it into half, so I have to find the middle element. So what I will do is left plus right minus left by 2. You can see even this is equal to right plus left by 2, but there are few reasons why we don't left plus right by 2, because sometimes the array length may be so big that left plus right will lead to a bigger number, and we cannot store that in the int. So there are few more other reasons also why we write like this, but it is the same as left plus right by 2. Now what I will do is I will recursively call this merge sort algorithm, but this time I will call that from left till mid, not the right one. That is the left part. So this is left part of the array. And then I will merge sort again from mid plus 1 to right. So this is going to be right part. Again, I will repeat the same process. In this left to mid part of the array, I'm going to again divide that into two parts. And again, whatever process is there, the next of this, that will be followed. Now here, I will be calling after we have merged these two arrays. So let us suppose we have got only single elements. What we have to do next is we have to merge, right? So I will write a method called merge. What I will merge? Array, left, mid, and right. I'm just telling whatever indexes are there. So left to mid I will merge, and then mid to right. I've just given the numbers. Now the method is missing, so I will be writing the method public static void merge. Here I will be writing int array and int left, int mid, int right. So the merge I have written. So here we will be having two types of arrays. That is two arrays which we need to merge. One will be ranging from mid to left, and then another one length will be right to mid. So here there are few calculations we have to write. So here I have to create the arrays to store the values. So I will be declaring the size of the arrays too. Int and one of the first half of array, it will be mid minus left plus 1. So mid minus left plus 1. As this is the size, I'm going to write plus 1 because these are indices. So I have subtracted it and plus 1. And int n2 is going to be same, right minus mid. That's it. Now, I'm going to create two arrays that is of these sizes only. So let me tell them as left array equal to new int of n1 and int right array equal to new int of n2. So what I will do is I have to put the values of the main array into these small arrays. How I will do is using a for loop. So I will create a for loop for int I equal to 0, I less than n1 and I plus plus. So left array size, I'm going to iterate to fill the particular array. Again, the same I will copy to fill the right array, which is n2 size. Now, um, so what here I will do is, here I will fill the left array of I. How I will do? So here array of left plus I. And here it will be right array of I equal to array of mid plus 1 plus I. So after I have filled the arrays, what I have to do, we will do the comparisons. So int I equal to 0, j equal to 0, and some k is equal to left. Here we have to merge these two arrays because the method itself is merge arrays. We have got the two arrays, that is left and right, and now we have to merge them. While I is less than n1 and j is less than n2. So I'm going to compare each element in these two arrays. So this is the filling of arrays. Fill the two halves. And now this part is going to be compare. Compare and add to array. So I is going to be the elements in the left array and j is going to be the elements in right array. At one point, I have told you that we will be having 5 and 8 as one part of the array. So that is one array and 3 and 2. Here, what we will do is we will take first, this will be sorted right after that. Okay, 5 and 8 and 2 and 3. Here, what we will do is if we take this as the left sorted array. So, let me tell you this. So this is the left sorted array and this is the right sorted array as I told in the explanation before. Just before the merging step, we have got this result. Now, this 2 will be compared with the 5. This is the left array and this is the right array. Here this is n1 elements and here n2 elements. I have taken this iterator as I and here the iterator as j. So that is the step we are doing here. Here I'm going to compare this element with this 5 and whatever is smallest I will put it first and then this I will be incremented to 3, that is 0, 1. I is the index and the value will be 3. This 3 will be compared with 5 again. Again, what is the smallest? It is 3 and then 5 is the smallest and then 8. So this step is this one. So here what I have to do is if left array of I is less than or equal to right array of j. So what I have to do is I will put the array of k, that is the main element or main array, the value of left array of I because that is the smallest. And then I will increment the I. Else, what I have to do? Oh, so this is not array, ARR. And then array of k will be written as right array of j. Because in this case, the j element is smaller and I will increment the j plus plus. After putting whatever value we got, I have to increment the k plus plus also, that is in the main array. So this is the iterator for the main array, to fill the main array. So now I have finished that. But what if elements in N2 I, that is the first left half of array, are completed, but right half array elements are left? Or what if the right elements are completed and left half elements are left? In that case, there is no point of comparison of two arrays. In that case, we will directly add the elements present in left array to the main array or right array to the main array. In this example also the same case happened. So firstly what we did is 2 and 5 we compared, we put 2 I is increased to 3 1, that is the value of 3. Now 3 is again compared with 5 and 3 is put before this happened. So now this elements are completed, that means the left array is over but the right elements are left. So here what I will do is I have to directly add the remaining elements of the other array to the main array, that is 5 and 8. Why? Because this is already sorted. We have already sorted the individual elements. So I will directly add that 5 and 8. This is the sorted array. That's it. So again, I will write a while loop. So while I is less than n1, that means the I didn't reach n1 minus 1. That is the last element in the first left half of the array. What I will do is, in that case is array of k equal to array, left array of I. So I will just take each element and put it in the array of uh, main array, and then I will increase this I and k. Same I will repeat for the right array, that is if j is less than n2, then I will just put the elements in the elements of the right array into the main array. So that is j and j plus plus and k plus plus. That's it. We have done everything we wanted to do. We have compared. Here we have compared and then we have also merged two arrays. Okay, so you can see this method has a constructor name. So let me name this method as merge arrays. Constructor means it is the same name as method name, the class name. So previously it was merge, that is the same name as the class name. So we shouldn't have that because we are not creating any objects with that method. So that's it. Now I will run the code and we will get the same output, 2358. So this is about the merge sort algorithm. Now let us go into the next algorithm quickly. The next algorithm is going to be the quick sort algorithm. So in quick sort algorithm, we pick a pivot. We partition the array and then we will recursively sort the array. Here, this might seem a little confusing. We will choose a pivot and then we will do the comparisons with it. And we will put the pivot into the correct position. That is, we can choose any element. So let me tell you in the simple words. Firstly, we will choose any element. Then I will find all the elements which are less than that and put it to the left of that pivot, and all the elements which are greater than that pivot to the right of that pivot. That's it. That is the first step and main step. And in the two parts, that is left half and the right half of the pivot, what I have to do is proceed the same steps. I will take any element which can be pivot in the left half And then again do the same process. Move all the elements which are less than the pivot to the left and greater than the pivot to the right. And the right half also same. That's why we have said that this is recursive sort. So we are going to partition the array into left and right halves according to the pivot, and then recursively do the same things for the halves also. It is not mandatory that the arrays will be in the half, because there can be a because they have a freedom to choose any element as pivot. There is no mention that we have to choose the middle element as pivot. So the left and right halves can be different sizes. So here we have the time complexity as n log n. In the previous example, why this is log n is because n log n is because we are going to divide the array into halves. That will be log n. And then we are going to compare the two arrays elements. And that will be big O of n. So in total, it will be big O of log n time complexity. Firstly, the important part is to understand these algorithms, and while you do them, you will be understanding the time complexity also. So here the best and average case is big O of n log n, and the worst case is big O of n square. The code part is fine, but we have to put pen on paper with examples. Like we can take arrays and then we can solve them. Then we will understand about this in detail. This use case is general purpose sorting and databases. And this is not stable because the sorting may lead the same elements to get swapped to. Now, let me explain with an example. 5, 3, 8, and 2. If I take a pivot of 5, what are the elements less than a pivot? 3 and 2. So I will place 3 and 2 at the left, and pivot will be here, and then 8 will be at the right. Now in the left part, if I take 2 as the 3 as the pivot, left array will be 2. So 2 and 3, and in the left array 2, I will take the pivot that itself because that is the only element present and it is already sorted. And then the pivot 8 in the right part, that is the pivot and it's already sorted. So what I've got 2, 3, 5 and 8, that is the array sorted. In the code, we have to do few operations. In the code only you will understand how we will do it actually. This is the basic idea of the quick sort. Let me open the VS Code now. So here again I have mentioned the same things. Now what I have to do firstly, I have a left element and right element, or we can take it as low and high. Let me write it low and high. So if low is less than high, here also similar to merge sort, we are going to divide and conquer because we are going to divide into left half and right half. But how we are going to divide is the matter. So here we have to find the pivot index. This pivot index, what we are finding in this step, is going to be the correct position of the pivot. In this example, if I take 5 as pivot, after arranging at a certain position, what is the index of that pivot? That we are going to find in this in pivot. Here I have to, here I cannot write the entire code, so I will declare another method, that is partition of array of low and high. and that this partition will return an integer that will be the correct position of the pivot. That will be 5 in our case. So just an example, if the pivot is 5, we will find the index of that pivot. Then I will again recursively call this quicksort method and array of low till pivot -1. That is the left half, whatever size it is, and then pivot +1 till high. We don't need to consider pivot because it's already in its correct position. We have to sort only the left part and right part. That's why I have written pivot -1 and here pivot +1. For this quicksort method, that's it. Because it will solve itself. But our only task is to find the partition that is the pivot index. So I will write the code for that too. Public static. Here we are going to return an int and partition of int array, int low, and int high. So partition. So now I will declare the pivot as the first element, that is low element. So array of low. Low is the least index and high is the highest index in the array. Now that I have chosen the first element as pivot, what I will do is, let me write two variables. Int start is equal to low and end is equal to high. Just so we can use these for our iterations and not disturb this low and high. I have declared start and end as two variables. Now, while the start is less than or equal to end, here what I will do is, I will check each element, that is the start, if it is less than the pivot. So first let me write the code and then I will explain. Start less than or equal to end, and then array of start is less than or equal to pivot. Here what I will do is start plus plus, and then while start is less than or equal to end, and array of end is greater than pivot, and minus minus. Here what I am doing is, I have to find any element which is greater than the pivot. In this part, whenever an element which is greater than the pivot is found, we will stop there. And here in this case, any element which is found which is less than the pivot. Here what I'm doing is, in the basic sense, I'm segregating the elements into less than the pivot into left part and greater than the pivot into right part. That's it. So the next step will be, here we have to swap, but what elements we have to swap is the point. If start is less than end, then we have to swap the start and end elements only. But after ending, we are going to swap the low and end elements. I will explain this with the example only. So here swap method is not there. So let me write the swap method also. Public static void swap. This is nothing, just we are going to swap two elements, int I and int j. So here I will write the same int temp and swap it with ith element is with jth element. Let's say. That's it. Here I have written the swap function. Now, to explain this one, this part, I will write an example which will be, so let me take some random elements. So 7, 6, 10, 5, 9, 2, 1, 15, 7. So I've taken some random elements here. That is, let's take this example array to explain the algorithm. And what I'm doing is I have considered the pivot, that is array of no. So let me take this 7 as the pivot for now. Now here I will write the first 7 I'm saying about. Pivot is 7. Here the pivot I'm writing is the pivot element. So in this algorithm, start is low, that is the index. Start is 0 and end is 0, 1, 2, 3, 4, 5, 6, 7, 8. So start is 0 and end is 8. These are the indices. Now the next step is while start is less than end. Is 0 less than 8? Yes, true. While start is less than end, yes. Array of start is less than pivot, less than or equal to pivot. That is also fine. So here the 7 is less than pivot. Yes, 7 is less than or equal to pivot. It is equal to pivot, right? I will do start plus plus. Okay. Now the start is equal to 1. So that is here. Is 6 less than 7? Yes, it is. So again, start is plus plus. Is 10 less than 7? No. Now the start will stop here. So this is ended now. Now here, this loop will start. Now the start is here. Now end will start from here. Is it greater than pivot? No, it is not because it is equal to pivot. So end will be 8 only. So in the next step, what will happen is if start is less than end, so yes, it is true. That's why what we will do is we will swap this second and eighth element. Now what we will get is 7, 6, and here 7 I will get because I have swapped it with the last element and then write the elements like this, 15 and 10. You can see something is happening here. This 10 has gone to the right part, which is greater than 7, and the part that is 7, which is less than or equal to 7, has come to before. Now, the pivot is still the same. The start is 2 and end is 8. Again, let's continue. Because still the start is less than end, we have to still continue. So I will update the start elements here now. So start is 2, end is 8, 0, 1, 2. So here the start is there. Is it less than or equal to 7? Yes, it is. So I will do start plus plus, that is 3. Is 5 less than or equal to 7? Yes, it is less than 7. So I will move it to front. Now 9. Is it less than or equal to 7? No, it is not. So I will stop there. So here the start will stop. Now, this end, again I will start from here. Is it greater than 7? Yes. Is 15 greater than 7? Yes. Is 1 greater than 7? No. So the end is going to stop here. So start is 4 and end is 6. So still the start is less than the end. So what I will do? So now I will be swapping the start and end elements. So what is the start element? That is the fourth, 0, 1, 2, 3, 4. That is the 9. So 7, 5. Here what I will get is 8, 7, 6. Here I will get 1 and here the 9 will be there. Now let me update the start and end elements here. So now the start is 0, 1, 2, 3, 4, 1. It is less than the 7, yes. Is 2 less than 7? Yes. Is 9 less than 7? No. So that start will be ending here. 0, 1, 2, 3, 4, 5, 6. So here it won't be coming. The start will end here only because we won't be moving forward and incrementing the start. So start will end at 5 only. Now, this end is here, that is 9. Is it is greater than the 7? Yes, it is. So we will move forward and we got 2, that is 5. So let me restart this process. Got stuck somewhere. So this happens mostly. So here 0, 1, 2, 3, 4. So here it is 1. So when the start, that is 1, is less than 7, yes it is. So I'm going to move forward. That is to 2. Now is this less than 7? Yes it is. So I will move forward again. Okay. So we will have to be very careful here in the steps. So now the start is at the 6. 0, 1, 2, 3, 4, 5, 6. That is at the 9. And this end is at the 9. Now here I will be checking if it is greater than the pivot or not. It is, yes, it is greater, and it is not greater when it comes to 2. Now the start is greater than the end. Now what we will do? We will not do anything because this loop is also ended. Now here, the only thing I have to do is swap the low and end. What is the low element? That is the 7. And end is going to be the fifth element, the fifth index, 0, 1, 2, 3, 4, 5. That is the 2. So now 2, 6, 5, 1. Now what we will get is 2, and then the 9 is swapped with 7. No, 2 is swapped with 7, right? 6, so what we have got? 6, 7. Yeah, here I have missed the 7. 2, 6, 7, 5, 1. Here I will get 7 again, 9, 15, and 10. Now we have got the pivot at the correct index. So what is the end? 0, 1, 2, 3, 4, 5. So here, this 7 is going to be returned. Not the value, but the index of 7. So here I have got is pivot index is equal to 5. Now, whatever elements are before this pivot are less than that, whatever are after that pivot are greater than the pivot. So now we can do the same process for the left half and right half and continue. And finally, we will be getting the array as what is the sorted array? 1, 2, 5, 6, 7, and 7, 9, 10, 15. It's better if you do this algorithm once on paper and then you will understand. So this was about the quick sort, a very long algorithm, but very quick because we are not going to use any extra space. That's why sometimes they say quick sort is better than merge sort in some case because here the time space complexity is less. Okay, so now I will share my screen again, the PPT. The quick sort was very interesting. So now let us take a quick summary. The summary table. So we have discussed about five sorting algorithms. The first three are the simple ones, and the next two are little confusing but efficient algorithms because the time complexities, if you observe in bubble sort, we have to do multiple comparisons. In the best case, that is, if it is a sorted array, then only one iteration we will do, and we will be seeing that all the elements are already sorted. That's why we won't do. So this is the only best case we have. Else, in average and worst case, we will be doing n squared times. That is n into n. So n times I will iterate the array, and again I'll compare with all the n elements. That's why n square. And the selection sort also the same. But here the best case is also n square. So you can see all the whatever we have got, I have summarized in this table. All these three are for small data sets or simple. And let us see the insertion sort, big O big O square, similar to bubble sort. It is stable, in place. So the only not in place algorithm is merge sort because we are going to use some extra space here. And then insertion sort is done, and then we have quick sort here, n log n time complexity. The worst case is n square, but merge sort n log n always. It is also a stable. For this, if it is stable or not, you can after this session you can try few examples taking same array and trying all the algorithms on that array and check if you take the same elements if their index is changing or not. After, I mean, not index, the order is changing. If we have the same element, let me take 3 and 1, 2, 3, 3 as I said, take the 3 as with some index. So take it as 3a and then 3b. So you can find if after sorting it is 3b and 3a or 3a and 3b only, if the order is preserved or not. That's it about this. You can take a snapshot if you want. Now, we have finished everything. Summary and recap. If you need a simple sort, then go for bubble selection or insertion sort. But if you need efficiency over the time, that means if you want less time complexity algorithm, then choose quick sort or merge sort. If you need a stable sorting algorithm, you can choose merge sort and insertion sort. You can even choose bubble sort. And big O of n log n always, then merge sort. So that was about this. So now let us have a quick quiz time. So which worst case time complexity of quicksort algorithm? You can answer in the chat box or on your mic and tell the answer if you know the answer to this. So now I will reveal the answer, that is big O of n square. And then the divide and conquer algorithm. Which sorting algorithm is based on divide and conquer? And all these, which of the, so here I have discussed about heap sort. Let me give the option as bubble sort. So I'm writing B here. Okay, my handwriting is pretty bad. Ignore that. So merge sort, selection sort, insertion sort, and bubble sort. Which of the following is divide and conquer approach? It is merge sort. And then the next question is, which sorting algorithm is always big O and log n? Merge sort, quick sort, selection sort, and bubble sort. Always n log n, it is merge sort. That's it about the quiz. So after this session also, if you want to explore some other sorting algorithms, you can of course revise all the algorithms which I have told you to be perfect in that. But other sorting algorithms, if you want to explore, we have heap sort, as I said before, then the radix sort, which uh, counting sort and bucket sort. In heap sort, we use a binary heap for sorting. You can search about that. Radix sort, sort numbers digit by digit, great for larger numbers. Counting sort, best for small range integers. Bucket sort distributes the numbers into bucket, then sorts each bucket. You can explore these. So sorting is a fundamental skill in boarding interviews, so we have to keep practicing. Even after listening to this or understanding once, I have faced it several times. I have forgot this quick sort many times. So we have to just keep revising the concepts. So if you want, you can connect with me on LinkedIn. And if any questions you have, we can discuss. Else, let's wrap up the session. If you want to expand your knowledge, you can expand it by visiting this website, that is learn.microsoft.com, and training. Here is a quick survey form which you can fill it to tell about the Microsoft Learn student ambassadors. And if you also want to become a Microsoft Learn student ambassador, then reach out to me and I will be guiding you through the process. And finally, thank you very much for joining me in this session to learn about various sorting algorithms. I'm very glad that you all joined. Thank you.